Good afternoon, everyone. I am Miss Rakhi Mandal, an assistant professor of Ishan Educational Institution, and it is my privilege to welcome our esteemed resource person for the fifth session of the second day of 4-day faculty development programs. Today's session is on generative AI, ethical consideration, intellectual property, and academic integrity. We are honored to have with us Dr. Mohammad Atique, professor and head of the Department of Computer Science and Engineering at SGB Amravati University and director of the UGC Malve Mission Teacher Training Center. He holds a PhD, ME, and BE in computer science and engineering, along with an MBA and an LLB. His area of expertise include artificial intelligence, and medical image processing. With over 30 years of teaching experience, he has made significant contribution to higher education through 68 research publications, 3 granted patents, 7 published patents, 5 copyrights, and 2 books. He has also served as an NBA and NAC assessor and trainer and has delivered more than 106 expert lectures at national and international platform. We are delighted to have the opportunity to learn from his vast experience and expertise. I am confident that today's session will be insightful and inspiring us for all. On the behalf of Ishan Educational Institution and all the participants, I extend a warm and heartiest welcome to Dr. Mohammad Atique. Sir, we are truly honored you by your presence. Now, request to kindly take over the session. Thank you.
Thank you. Thank you, madam. Very good afternoon to one and all present in this session. Okay, as far as this session is concerned, we'll have a detailed look at that is how to integrate AI into teaching and research. That is the focal point of this particular session. Okay, so just allow me to share my presentation. Okay, as all of you know that we are witnessing a lot of application in the recent past built on this technology, that is AI. Okay, so before directly jumping into various aspects of AI, okay, we need to understand some basic aspects of this technology, and then definitely we'll move ahead with you may say some advanced concept like say RAG and so on. Right. So having said this, just allow me to share my presentation. I hope my slides are visible to you.
Yes, sir. Yes, sir. Yes, sir. It is visible.
Thank you. Thank you. And this is what is there on the agenda, and probably we are in the presentation mode. All right. So before directly jumping into what is AI and all, okay, we need to understand what is human intelligence. Okay, I don't know whether you are comfortable with interacting with me on various aspects of AI, but before moving ahead with all those stuff, okay, I would love to, you can say, listen to your maybe argument or counter argument that whether this technology is good or bad. Okay, so there are two sides of a coin. Right? Since I'm from computer science, so some of you may feel that I'm a little bit biased, but this technology is evolving with a jet speed, right? And many times it is also referred to as what they call it as the disruptive technology, right? But this is a disruption which is, as a matter of fact, being witnessed by all sectors, okay? And EdTech sector is no exception in that regard. Okay, so in education technology, again, we are feeling a lot of disruption due to the evolution of various AI tools and so on. So we'll dig all those aspects of this technology, that is AI, and definitely we'll touch upon one important thing, that is how to use this technology without making any compromises on ethical front, right? So having said this, okay, before directly jumping into what is AI and all, okay, we need to understand what is human intelligence, right? So human intelligence, I don't know what is your take on this, but let's say if you can come up with certain attributes, okay, which the nature has given us, okay, which makes us, you may say, intelligent, right? So what are all those attributes? Anybody of you, I don't know whether you are comfortable or whether you enjoy the right to unmute yourself, but if it is so, I'll be happy to hear from you. So what do you feel? What human intelligence is all about, right? I'm right now going through. Let's say if you are not comfortable in unmuting yourself, then you may uh, go ahead with you can say putting your comments in these chats and chat and so on, right? So I'll go through it, but sorry, I'm not finding anything over there. Anyway, so what is your take on this? What do you feel? What human intelligence is all about? Okay, so there are some peculiar factors, okay, which makes us little bit different from all other living organism on the earth, right? And what are all those attributes? Those attributes are nothing but, you can say, the ability to learn, okay, ability to reason, okay, that is whenever you take some or the other decision, okay, you can very well justify that decision. That is how you arrived at that particular conclusion and how you took that particular decision. So reasoning capabilities, or you may say comprehension capabilities, okay. And last but not the least is, once you have been trained in a particular domain, okay, we as a human being, we are capable of applying that knowledge into altogether novel or challenging situation. Okay, let me give you a brief, very, you can say, simple analogy in this regard. Let's say you want to learn how to drive a car, and whenever you undergo training, okay, for you can say driving the car, okay, most of the time, okay, you are the training school people normally take you to either on highways or in playground, right? But you will never encounter that kind of ideal scenario all the time. Okay, due to some or the other reason, you have been forced to drive in a downtown kind of a situation wherein you are facing a lot of traffic. So what do you do in that case? Whether you call your trainer or you apply the knowledge, whatever you have acquired during training, okay, to that novel or challenging situation. So most of us, we go ahead normally with the, you can say, applying that knowledge, whatever you have acquired in the training, to altogether new or challenging situation, right? So these attributes makes us intelligent. Let's say by some means, if we are in a position to embed these attributes into a machine, okay, we may call that machine as an artificial intelligence. So if you think on those lines, okay, we can come up with a definition of AI, very vague definition of AI, you may say. It is nothing but the study of mechanism that think and like act like humans. So thinking capabilities and taking decisions, okay, that is acting like human. Okay, that is the simplest definition of AI. Or you may say simply any technique that enables computer to mimic human behavior. That is the another important aspect of this AI. So mimicking human behavior covers all those aspects which we have already talked about with regard to human intelligence and so on. Now, having said this, okay, most of us, we feel that this technology is completely new. It has uh, erupted all of a sudden, but that is not the case. If you look at the historical perspective of this technology, okay, you will be surprised to note that this term, that is AI, it was tossed for the very first time way back in 1956. and the scientist was, or the person who tossed this particular term was John McCarthy. So roughly 70 odd years have passed. Okay, earlier we used to have certain issues with this technology, and that's why it was a bit difficult to build application based on this technology. Now, if you look at the evolution of AI, okay, this technology has evolved in four phases. What are all those phases? The very first phase is what they call it as the traditional AI or the classical AI. Okay, so traditional AI or classical AI is the early era of AI, wherein the systems which were built using this technology were called as expert system and so on. Right? Then we entered into an era what they call it as machine learning. Okay, then deep learning, and at present we are into an era of generative AI. So we'll just try to understand all these phases of evolution of AI. Okay, starting from traditional AI to the generative AI, and probably at the end we'll have some advanced concept in this regard. That is, again, Gen AI has got a lot of limitation. Okay, so we'll talk on those lines, and then how to solve those issues. Okay, that is what is there on the agenda. So having said this, the traditional AI systems, where the systems wherein we give the computers the ability to do tasks that traditionally only humans have been able to, right? So what do we do in case of traditional AI is we interact with the human expert working at that domain. So let's say you want to uh, devise an expert system for medical diagnosis. Okay, so you will approach some or the other doctor, ask him or her, that is, how do they approach, okay, and diagnose disease with regard to a particular patient. And based on their responses, what do we do? We write down if then else rules, okay, hard coded rules, okay, in the form of if then else, okay, and we code this explicitly, write programs using some or the other high level language like say Lisp, Prolog, or some maybe any other language for that purpose you may use. Okay, and these systems were referred to as expert systems. Okay, typical examples are, you may say, playing chess. Okay, you must have heard about that world chess champion playing against a computer program, right? So that is a classical example of this traditional AI or expert system. Right. Another example is the homeopathy expert, or you may say a washing machine, and so on and so forth. Right. So in case of a washing machine, what is it exactly? Okay. In case of a washing machine, is the pretty simple problem to solve or to automate. Okay. What do we do? Let's say you are dealing with 3 or 4 parameters in that case. So you can devise around 27, 30 odd rule, and you can embed all those rules into a microcontroller chip. Okay. And that chip you will place inside the washing machine, and it will take control of all the components installed in a washing machine, and it will behave as if some human being is washing the clothes. Okay, so that is the best simple example, but there were limitations with regard to this traditional AI system. So that's why this approach was not popular. And what are all those limitations? Let us have a look at those things. The very first thing was these systems were time intensive. Okay, let's say if you are dealing with a very simple problem like washing clothes, then in that case your rule base is quite small. But if you are dealing with a complex problem, let's say medical diagnosis, so in that case definitely your rule base would be large. Okay, and so as to search the entire rule base, okay, it is bit time consuming. Okay, so that was one of the biggest issue with all these traditional AI systems. The another major issue was that it does not generalize to new situation. Let's say you have built a medical diagnostic system for diagnosing various diseases, and you are facing a COVID-19 kind of a scenario. So if you give symptoms of COVID-19, okay, the system will not give you the exact answer. Rather, it will come up with a simple message that is no match found, unable to diagnose. So no match kind of a scenario, AI, right? Then the another important issue was That is, as these systems were built based on the interaction with the human expert, okay, so we as a human being, we suffers from this paradox, what they call it as Balinese paradox. That is, many times we know more than we tell. Okay, so many times we are reluctant to disclose. So definitely, if I am not explaining everything to you, how you will write down rules for all those possibilities? So that was the another issue. Then we cannot write down rules for all possible situations. Let's say if you are dealing with a very complex situation, okay, wherein there are hundreds of attributes. Okay, so if there are hundreds of attributes, then definitely it will lead to, you can say, thousands of combination. Okay, so it may lead to what they call it as the combinatorial explosion. So that was the another issue involved with this traditional AI, and that's why there were only limited application of this technology. Then what has happened? We moved into an era of what they call it as machine learning. Okay, let us try to understand what this machine learning is all about. So in case of machine learning, what do we do? Instead of explicitly programming the computer, we expose a computer program or a computer with hundreds of input output data pair. We call it as data set. Okay. For this input, this is the output. For these symptoms, this is the probable disease. For these symptoms, this is the probable disease, and so on. So we call it as a data set. Okay. And what do? We pick some or the other statistical technique. And what is the objective of that statistical technique is to learn the relationship between the input and the output. Okay. So what we are trying to do using machine learning is we are giving, you can say, hundreds of data pair, data sets, input output data set, and asking it to learn. Okay. By using some or the other statistical. Now, what are the possibilities under statistical techniques? You have numerous possibilities here. Those who are from statistics, they must be well acquainted with these things like, say, linear regression, logistic regression, classification and regression, support vector machines, random forest, gradient descent, neural networks, and so on. So even though neural networks is the last one, but it is one of the most popular used by all the large language models. So definitely we'll have a detailed look at these neural networks. But if you look at the strategy in case of gradient descent, this was proposed way back in 1880. So this technology is not at all new. The roots of this technology are deep. Okay, so it has not erupted all of a sudden. What has happened due to the, you can say, the state of the art hardware available at the local level, we are in a position to build hundreds of applications based on this technology, and that is why we are feeling the heat. Okay, but there is no other reason. This is quite old. Okay, early systems were having a lot of limitation, which we have talked about. But in case of machine learning, the issue was, now again, machine learning suffers from some problems. Okay, and what was the problem? Rather, the only problem was, in case of machine learning, we have to have structured data. But in real life scenario, you will not have structured data for all the problem domain. Okay, let's say if you are dealing with, you can say, uh, a medical diagnostic system. Okay, so in case of a medical diagnostic system, okay, you will not have data in the form of numbers. Okay, so what you need to do is you need to, you may say, pre-process that data. And what that pre-processing is all about, it is converting that data into numbers, and to be very precise, numbers between 0 and 1. Now, how do we do that? Okay, it is pretty simple. Let's say certain parameter values you are getting in 2 digits, certain parameter values you are getting in 3 digits. Maybe it is body temperature or blood pressure. If you are recording all those parameters of a particular patient, so some values will be single digit, some of them will be double digit, 3 digit, 4 digit, and so on. What you can do, you can divide those things by some constant. If it is a single digit number, divided by 10. If it is a 2 digit number, divided by 100, 3 digit number divided by 1000, and so on, so as to get the values between 0 and 1. And now this process is called as pre-processing. So this is the fair overhead associated with machine learning. Because if you don't have numeralized data or a structured data, it is not possible to train machine or carry out machine training or machine learning. Right. Now, having said this, we then we moved into an era of what they call it as the deep learning and the generative AI. But as I have told you, that is in case of uh, this machine learning, we are using neural networks as one of the you can say statistical techniques. So, what are neural networks basically? Neural networks are inspired by, you can say, the human neuron. Okay, and this is the structure of a biological neuron. Okay, now what is there in a biological neuron? Biological neuron, we have dendrites through which we give input. Okay, and then it is being processed by the nucleus, and whatever is the output, it is given as the input to the next neuron in the neural network. So this way we have got millions of neurons and they are connected with each other. Now you look at the speed, tremendous speed the God Almighty has given us. That is, how do we compute? Okay, and that too so quick. Okay, let's say if I throw some object, so you very well know how to, within no time, okay, you can take decision and we will move about, right? So based on this biological neuron, we have an artificial neuron, okay, or artificial neural network, and this is the structure of a ANN. Okay, what is it? It is basically there are two neurons in this case, X1 and X2, and with each neuron there is something what they call it as some W is associated with it, right? That is the weight. Okay, in case of biological term we call it as a synaptic strength of that particular neuron. Okay, synaptic strength of that particular neuron, whereas in case of artificial neural network we call it as a weight. So these weights are responsible for learning. So during training, what do? We learn the value of these weights. Okay. And as I have told you, that is the objective of applying some or the other statistical technique is to learn the relationship between the input and the output. So this is what we are trying to learn in this case. That is, why is the output in this case? So why we will try to learn, okay, in this manner, that is these values you will learn. That is 0.32, okay, that is nothing but the x1, oh, sorry, w1, and 0.77, which is nothing but the w2. So this is what exactly we are trying to learn using this artificial neural network. So we use some or the other statistical techniques. Neural network is one of the basic techniques, but the things are not that simple. Okay, as I have told you, two neurons are not sufficient enough to solve any real life problem. So we have to have hundreds of neurons. Okay, and that is why we have a structure what they called as a multi-layer perceptron. So what is a multi-layer perceptron? This is, you can say, the schematic diagram of MLP, okay, wherein you have input layer, okay, then you have got weight associated with each neuron that is depicted by X0 to X1, and the weights are depicted by W0 to Wn. Okay, then what do? We simply multiply this, we compute a weighted sum. Okay, how do we compute the weighted sum? It is x0 into w0, x1 into w1, and so on, xn into wn. Okay, so whatever is the value of that weighted sum, then it goes through some non-linearity. We'll not go into the details because that is not our objective to learn at this point of time. Okay, our objective is to learn, that is, how do we train a neural network? Okay, on in a broader sense. Again, we'll not go into the detail because there are many things involved. But it goes through some activation function wherein you have, you can say, functions like say ReLU or sigmoidal function, and then you get some or the other output. Let's say in the first run, we are feeding all those values. Let's say you are dealing with a handwritten numeral recognition. Okay, so you have extracted around 40 odd features. So you will feed all those features from X0 to X39 as the input vector. Okay, random value of weight. Okay, as I've told you, all these values of x1 and no, sorry, x0s and w0, it lies between 0 and 1. So we'll start with a random value of, let's say, 0.5 for all the weights in the first run. Okay, what do we do then? X0 into w0, and whatever is the output goes through the linearity and you get some or the other output. Let's say the actual output you are getting is 0.8, okay, and the desired output is 1.0. So there is an error of 1 minus 0.8, that is 0.2 is the error. Now what you can do, now your objective is to minimize this error. Okay, so what you can do, now you cannot change the input. What you can change is you can only change the value of this way. That is what exactly we are trying to learn. So now there are two possibilities. Okay, either you will decrease it or you may increase it. Okay, let us try to go on the right hand side. Let us increase it by 0.1 and again observe the result. When you made all these weights as zero point 0.6, earlier it was 0.5. Okay, what has happened? Again, you observe the result. Okay, so the result is, let's say earlier the output was zero point 0.8, now it is 0.9, meaning thereby the error has been reduced from zero point 0.2 to zero point 0.1, meaning thereby we are in the right direction. So we go on increasing the value of weight till we get the minimal value of this error, that is 0.00, theoretically speaking 0. Okay, so at that point of time we will stop training and we declare that the training is over, and whatever are the values of these weights, okay, we declare that those weights are normalized. Okay, so this is what is in a broader sense, this is how we carry out the training. Okay, or how do we learn using machine learning, right? So again there are three important, you may say, strategies one may adopt. One is what they call it as the supervised training, wherein you know the input and you know the output. Okay, that is, the mapping is from known to known. But let's say if you know the input but you are not aware of the output, okay, that is, you are mapping from known to unknown, it is called as unsupervised training. Okay, and the third and the most popular training strategy is the reinforcement training, wherein we it is, you may say, it is simply an approach wherein we learn by trial and error. Okay, that is the best analogy is whenever a small kid learn how to walk, okay, so he learn by trial and error, right? So reinforcement training is of that sort. Okay, and this is, as I said, is the most popular training strategy and is being used by most of the popular, you can say, the large language model like say ChatGPT and so on. Okay, so having said this, this is how the training takes place. Okay, but the things are not that simple. Many times you are stuck up in the local minima. Okay, there are ways and means to come out of that local minima and move to the global minima and so on. But what I am trying to emphasize here is, in a broader sense, this is how do we train the neural network, right? So there are different terms like say momentum terms, certain constants are being added, okay, to come out of that local minima and so on. So in training, what do? We update the weight. Okay, that is per sample updating. We update the weight. Okay, and we epoch. We carry out this activity n number of times. So that is whenever you move from this input to the output, this is called as one iteration or one epoch. So you may have 500 epoch, 1000 epoch, or 10,000 epoch, depending upon the complexity of the problem and so on. So epoch is nothing but the iteration. When you cycle through from the input to the output, that is called as one epoch. Okay. So this is all about, you can say, the training strategy and so on. Then we moved into an era of what they call it as deep learning. So deep learning is nothing but neural network. The only difference is that in case of deep learning, the number of layers are quite large. Okay, that is, we have n number of layers in case of a deep learning architecture, and that is why they are referred to as a DN architecture, right? So deep learning architecture. Okay, in terms of input output modalities, if you compare, okay, this with you can say the machine learning. In case of machine learning, we have to have numeralized data or structured data. That is the only possibility in case of an input. Whereas in case of deep learning, you can give structured as well as unstructured data. Now, what do I mean by unstructured data? That is, I can give images as well. Okay, images as well. And what kind of output you can expect from these deep learning algorithms or deep learning architecture? You can expect structured data as the output. Okay, and the best example is your unlocking of mobile through face recognition. Now, this feature is so common. Okay, earlier we used to have that biometric kind of recognition system for unlocking your phone. Now we have face recognition that is there almost. So, what is it exactly? Some DL algorithm is being executed. Okay, so whenever you purchase a new mobile handset, what do? You give some training to it. Okay, by exposing your face from different angles. So what it does, it will capture certain features from your face and it will learn. Okay, and those values will be stored in the weights as I have explained to you just now. Okay, so all those values, okay, will be stored in the weights, and then next time once the training is over, next time when you switch on your mobile, okay, what it does, it will capture once again your face in a real time manner, extract few features, and it will compare with the stored features. If there is a match, okay, your mobile will unlock, or otherwise you will get some appropriate error message displayed on your screen. Okay, it will say I'm sorry, I am unable to recognize. Okay, please enter your 4 digit or 6 digit code. Right. So deep learning algorithm are being used extensively in numerous applications. I tell you, say for example in traffic or the RTO department, they are using it. Okay, for checking the speed of a vehicle. Okay, and according, let's say you have a speed limit of 60 and you are driving the car with a speed of 80, it will capture that real time image and you may receive a challan along with the proof of your vehicle. Okay, at that point of time with real time date and time, all everything will be tagged appropriately along with the location. Okay. So in case of deep learning, okay, what exactly we are trying to do is we are trying to give input as structured or unstructured, and that is the real power of this deep learning algorithm. And the output is again structured only. Again, we have only limited possibilities here. Then we moved into an era of what they call it as generative AI. Okay, this is the present era we are into. Okay, so we are having hundreds of tools based on this you can say the philosophy, what they call it as the generative AI. So even though it is a small subset of AI, okay, so AI is a superset, then we have machine learning, then we have deep learning, and the innermost layer is the generative AI, you may call it, right? It is the small subset of AI, but in terms of, you can say, uh, features, it is very feature rich. Okay, what you can do using this Gen AI tool, okay, you can create new original content, completely new original content, which didn't exist before, right? Such as images, text, or music. Okay, and that too quite easily. Okay, if time permits, I'll show you some of the, you can say the demonstration of some of the tools, how you can do that. But these tools are so powerful that is, you can create, uh, you can write a research article, okay, completely new research article, but whether that is correct, okay, ethically it is not at all correct, right? One should not use it for generation of idea. However, you may use it for some other purposes. What are all those purposes that we'll see in the discussion in the slides to come, right? But these tools are so powerful. So some of you may argue, okay, sir, it is challenging our creative and innovative capabilities. Okay, I do agree with you. This is dangerous in some of the, you can say the developed nation. The usage of this tool, particularly for student community, is banned. Okay, but as far as our nation is concerned, we do not have any regulatory guideline in this regard. Okay, that's why we need to define our own boundaries. Many times I used to say that is, you need to define your own boundaries. As on date, we do not have any guidelines. Okay, but definitely in due course of time, okay, the government is very serious about it. Okay, they will come up with certain guidelines in this regard. That is the usage of AI for teaching and research. But as on date, we do not have any regulatory guidelines or any regulatory framework in this regard. Okay, so you need to define your own boundaries. Okay, you need to define your own ethical principles for dealing with all these tools and so on. Now, in terms of input output modalities, what you can do using these generative AI tools, that one has to understand as a user. Okay, so in generative AI, okay, the input you can give is completely unstructured. Okay, that is, you can give text or image or text plus image or audio or video or whatever you feel like. Unstructured meaning thereby completely unstructured. And what about the output? Again, you can expect completely unstructured output in this case. Okay, so that's why we have got numerous possibilities here. And what are all those possibilities? Possibilities are like you write a prompt, okay, and ask it to create an image. Okay, it will do it for you, right? Or the other way around, you may say you can give an image as an input, okay, and ask it to describe. Okay, it will come up with that description quite easily. Then text to music is possible, text to text, which is the most common one. So we have lot of possibilities here in case of generative AI. And what is the true power of this generative AI tool is their multi-modal functionality. That is, you can give anything as the input and you can expect anything as the output from all these tools. And that is the true power of these generative AI tools. But none of these tools are available free of cost. And there are reasons to it. The basic reason behind that is these tool, okay, their cost is quite high. Okay, this is the data which I have captured from Stanford University 2024 AI Index, quite old, you may say, but so as to simply establish that the training cost is really very high. Okay, if you look at the original transformer model, it was only $930, but GPT-3 it was 4.3 million US dollar. GPT-4 78.4 and Gemini Ultra 191.4 million. Okay, and that's the reason the beta version of these tools are available free of cost, but their pro version is many times paid. Okay, now let us try to sum up whatever we have discussed up till now. Okay, that is just I will just try to compare the traditional AI with the generative AI in terms of certain parameters. Okay, so what are all those parameters? Okay, those parameters are the primary goal. If you look at in case of traditional AI, it was merely a recognition and classification. In case of generative AI, it is creation and synthesis. So creativity is being challenged by these. And I hope all of you will appreciate that how dangerous it is, right? So what about the output type? In case of traditional AI, it was merely predetermined label or prediction, predictive capabilities only. That is, it will predict or classify. But in case of generative AI, it is new original content. That is text plus image plus etc. Okay, you can think of anything by these tools. These generative AI tools are capable of doing so. What about the data usage? It analyzes data to find specific things. Okay, whereas Gen AI it learns from the data. Okay, so it is learning from whom? From the data. And what is the objective? Is to mimic and create. Okay, mimic what? Mimic human behavior and carry out some creative activity. What about the interaction? Okay, mostly one way, that is input to the result, whereas generative AI is completely interactive and conversational. That's why many times while interacting with these tools, you realize that someone is sitting on the other side of the, you can say, your screen and responding to your queries. Okay, so it is interactive and conversational. Okay, then you may ask another query, it will respond to you. So you may feel as if you are interacting with some human being sitting on the other side. Okay, and that is the true power of this generative AI tool. Right? Now, having said this, what are the core components of this generative AI? Okay, so there are basically, as a user, we must be well acquainted with these things. Okay, so there are models, what they call it as the base model. Okay, which in general terminology, many times we refer to it as large language model as well, that is LLM. Okay, what are all these LLMs? These LLMs are capable of, you can say, understanding something written in natural language. Okay, now you don't require any computing knowledge, okay, or any programming skill for interacting with these tools or developing something using these tools. Okay, I'll show you if time permits anti-gravity. Okay, Google Anti-Gravity. If you download that application, it is a product from Google only. Okay, you download it, install it on your machine, and write a prompt. Ask it to create a full-fledged application for uh, you may say you may ask it to create a full-fledged application for generating lesson plan, PowerPoint presentation, and whatnot, whatever is needed, okay, in your daily teaching or learning activities, right? So these tools are really strong in some areas. Okay, the very first thing, as I've told you, that is they are capable of understanding the natural language. Then they do have capabilities to perform tasks like writing, translation, and summarization. That too quite easily and with 100% efficiency, right? So that's why many times people say that this technology will kill certain jobs. Okay, that is up to some extent correct. Upskill or reskill yourself, okay, and use these things for your day-to-day activity. There's nothing wrong in that. Okay, so foundation models or the base models are nothing but the LLM. Now, the another important aspect of this large language model is, okay, they are capable of predicting the next word in the input sequence. Let's say if I give all that glitters, okay, as the input, okay, this LLM or any LLM, okay, it will come out with the answer is not gold. So they are capable of predicting the next word in the input sequence, okay, and that is the true power of these large language models, right? Having said this, there is another important component of this Gen AI, what they call it as the transformers. So what are transformers? So transformers are having, you may say, some mechanism, what they call it as the attention mechanism. And this attention mechanism is capable of understanding or grasping the context in which the prompt has been crafted. Okay, so as I've told you, that is whenever you interact with these tools, you have to write down something in English like statement. Okay, that is referred to as a prompt. Okay, and this prompt is basically processed by that large language model. Okay, so these LLMs are capable of understanding each and every word and the sentences, but it will not stop there. It will understand also the context in which it has been crafted. Okay, so this context is definitely, it requires some sort of intelligent capabilities, right? So these transformers are capable of dealing that kind of a scenario. Then you need to many times train and fine tune these models. Okay, the problem with this model is they are pre-trained models. Okay, the training is carried out on some existing data. Okay, available from various and maybe Wikipedia and so on. Okay, so many times they are not aware about you or your organization. Okay, and that's why they give similar treatment. Okay, but let's say I want to adopt a particular tool for my own personal usage or my organizational usage. Then in that case, definitely I need to carry out this training and fine tuning. Okay, so I need not have to retrain it. Okay, sorry, I need not have to train it from the scratch. Rather, I can retrain it with my own personal data or organizational data, and then I may start using that tool for my own organization and so on. Now, what about the use cases in case of academia and research? Okay, there are many things which you can do quite easily using these AI tools. Okay, and I don't feel anything wrong as far as if you adopt these tools for teaching learning. There's nothing wrong in that. Okay, but research, okay, you need to be a little bit careful about, because there are a lot of, you can say, issues like, say, ethical usage of AI, and then responsible usage of AI and so on. Okay, so we need to be aware about all those aspects while using all these tools for research. But having said this, for research, again, up to some extent, like say, you may use it for summarizing the research, dense research paper, okay, which I will demonstrate if time permits. So there are certain use cases in both education and research, and with regard to commercial usage, you name the area. I tell you, you'll find some or the other tool for that particular purpose. So whether it is healthcare or finance or marketing or any other area, or maybe you name the area, you'll find some or the other use case possible with this Gen AI tool. And that is why it is growing with such a great speed, right? Having said this, we as a user, we need to know certain characteristics of these large language models. Now, I'll elaborate on only two important aspects. These large language models are capable of understanding the text. Now, how do they understand the text? They are capable of understanding the text by understanding the words or the sentences, and they many times they go one step beyond. That is, they are capable of understanding the context in which that prompt has been crafted. Right. Then the second important dimension is once they have understood the text, okay, they are capable of text generation. But what kind of a text they are capable of generating? Look at the characteristics. So these LLM basically generates coherent and contextually relevant text based on the input. And that is the true power of these large language models. Right. Now, having said this, how do these LLM works? Okay, these are the 5 steps. Again, we are looking in a very broader sense. Okay, we'll not go into the detail. For example, if you simply, if I simply try to explain this embedding, okay, it will require minimum 45 minutes to 1 hour, right? Because there are various techniques, there are various issues, and so on. But anyway, being a user, okay, we need to know all these basic concepts. So tokenization, that is, what do? We break the prompts into different words. So for simplicity, you may assume each word as one token. But the things are not that simple. Okay, it is more than that. For example, in a word, if you are putting ing at the end, or if you are putting es at the end, okay, it will be considered as another word. Oh, sorry, another token. So that's why I said many times it is more than the number of words. Okay. So all these ing, es make sense, okay, because they are typically used for understanding the context, okay, in which the prompt has been crafted. Then self-attention. These model basically they assesses the, you may say, the context. Sorry, just like you and I, we are capable of identifying the important words, okay, for understanding purpose in a statement. Okay, on the similar line, these tools are again capable of doing so. Okay, then predictive capabilities, I think I've already talked on this. Okay, then we have response generation. So at the end, the final step or the fifth step is the response generation. So what do? They generate response at the end. Okay, they generate response at the end, response generation. Now we are left with what? We are left with only one thing, what they call it as the prompt engineering. Now, how to write a precise or a more effective prompt so as to get the desired output? That is the question here, right? Okay, and that has given birth to one complete new area of engineering, what they call it as a prompt engineering. Okay, prompt engineering, or many times there's one more area, okay, what they refer to it as context engineering. So these two things are different, as a matter of fact, but these are the two emerging areas of you can say interacting with these tools effectively. Okay, so how to write prompt, how to write precise prompt? Again, there are numerous prompt engineering techniques. Okay, we'll not go into the details of all, but few basic techniques, being a user, we need to understand. Okay, the very first technique is what they call it as the zero shot prompting. Okay, wherein you don't give any example. Okay, this is the manner in which most of us we interact with these tools whenever we are interacting for the very first time. Okay, you pose a direct question to these, you can say, tools, okay, asking them to explain or elaborate a particular phenomena or object and so on. Okay, so that is zero shot prompting. Okay, so many times you get generic responses generated by these tools because you are not giving any example. So it is bit difficult for the tool to understand what exactly you want. Now, let's say if you give one example, okay, if you give one example, it is called as one shot prompting. Let me give you one simple analogy. Okay, probably that will clear your idea what I'm trying to emphasize. Okay, in one shot prompting, what do? We give one example, okay, and ask it to generate. Now, here I will get more tailored responses. Why? Because I have given one example. Say, for example, I want to create a tagline for a product which I am manufacturing and I wish to launch it in the market. So, for marketing purpose, I want to create a tagline for that. So what you can do in that case, you can simply look at the taglines of your competitors. Okay, say for example, you are into automobile industry and you are producing a motorcycle, okay, which you want to launch in the market. And let us assume that your competitor is Hero Honda and their tagline is "Fill it, forget it." Okay, if you give this as an example, okay, fill it, forget it as the example, and ask it to craft a tagline for your new product. Okay, what the tool will do, it will analyze this example. Okay, it will come to know that the user do not want more than 4 words. Okay, that is the number of word limit is merely 4. Second is, second important thing is each word must depict some or the other USP of that particular product, like mileage and so on. So it will think on those lines and it will give you more tailored response, right? So this way you may give one example. If you are giving more than one example, it is called as few shot prompting. So one shot prompting, zero shot, then one shot, then few shot. In case of few shot, you give more than one example, that is maybe 2 or 3 and so on. Okay. Now there is one more thing, okay, what they call it as the role prompting, wherein you may assign a role or persona to any of these tools. That is, you may say, assume you are a research assistant and then you are asking your query. So it very well understand what is the role of a research assistant. So you may, this way you may assign any role, like say, you may say, assume you are a vice chancellor of Sant Gadge Baba Amravati University and then you are asking your query. So what it will do, it will go through my university website. Okay, it will extract the relevant data, the roles and responsibilities along with the direction, okay, the different notification, and it will craft the answer. Now the scope, you what you are doing exactly, what you are achieving by assigning a role, you are specifying the scope of that, you can say answer. Okay, and accordingly it will create, you may say, uh, responses. So you will get more tailored responses in this case. You assign a role, okay, that you can see. Then chain of thought, wherein you are breaking down one big task into smaller one and giving it one after another. Okay, that is COT. Then meta prompting is there, wherein you are asking the tool to craft, uh, you may say, the prompts for you. But this definitely requires more expert level of reasoning and sophisticated, you can say, the responses. Okay, that it is not that easy. Then tree of thought, wherein it will explore multiple possible paths. Okay, let's say for a single solution, let's say you want to visit from one place to the, or rather you want to move from one place to the another. Okay, you have got 4 or 5 possible paths. So it will explore all those paths and it will give you the most optimal path in terms of toll or any other parameter, maybe road condition, traffic condition, and so on. That is tree of thought. Then prompt chaining, it is, which you may call it as a multi-step kind of a thing, right? And so on and so forth. Now, being a user, there are few important parameters we must be concerned about. Many times we are not aware, and that's why many times we are disappointed while interacting with these tools. And what are all those parameters? Again, not possible to cover all the parameters, but few important parameters which we'll discuss here. So the very first one is what they call it as the temperature. Okay, the range of value the temperature can acquire is between 0 and 1. Okay, you may set it, let's say if it has been set to zero point 0.0, then in that case, definitely you will get more, or you can say, generic responses generated by the tool. If it is set to zero point 0.6, okay, or zero point 0.8, you will get more creative responses from the same prompt. Okay, So how this parameter has been set, okay, that is the most crucial aspect. Okay, I'll show you that is how to set it and so on. Okay, so it is basically you may say it is the value of this temperature is directly proportional to the creativity or randomness aspect. Okay, it will increase the randomness or it will increase the creativity and so on. Then we do have max token, which defines the length of the response. Okay, so if you use consume more tokens, definitely you will get more detailed answer. Okay, so you can set that parameter as well. Let's say you want to craft answer in a specified word limit. You can set this parameter, that is top p, which is also called as nucleus sampling. Okay, so let's say I want to create a abstract, okay, wherein the word limit is 200 words or 250 words. So I can do so by simply setting up this parameter. Okay, top p. So it will craft the answers within that specified limit. All right. Then frequency penalty and presence penalty. Many times we get redundant responses generated by these two. If you want to avoid that, you need to set these two parameters, okay, in that manner. Okay. Now, does this mean that LLMs is the end of the story? Now we do not have any problem with regard to this large language model? The answer is a big no once again. So these LLM again suffers from n number of problems. So what are all those problems? Number one is the hallucination. Okay, the very first problem is the hallucination. Okay, what do I mean by hallucination? I'm really sorry for the interruption, but anyway, so again, these tools has got numerous problems associated with them. Okay, and this slide will give you an idea what are all those problems I'm talking about. Okay, the very first problem is the hallucination, right? That is, it will answer a query, okay, that it doesn't know. Okay, it is very similar to when you interact with your student in viva voce examination. Student doesn't know the answer, but he or she will try to give you some or the other, probably the wrong answer. So that is another issue with regard to this large language model, and that's why many times if we over rely on the stuff generated by these tools, okay, you will face the music, right? Then bias is the another issue. Okay. Then knowledge cutoff. Let's say, as I've told you, that all these large language models, they are pre-trained on some data. So let's say if a tool has been trained on up to maybe the data available up to a specific date, like say 31st of December 2025, then whatever has happened from 1st of January to 23rd of July, that is not known to the tool. Okay, so that is called as cutoff, knowledge cutoff, right? Then it doesn't know about you or your organizations. Okay, so they are not aware, and that's why they generate similar responses. Okay, irrespective of who is asking the or who is crafting the prompt and so on. Then training cost is high. Okay, which I think we have talked at length. Okay, in our earlier discussion. Then the another issue is the latency. That is the what they call it as the time taken to get an output. Okay, so many times they are slow. Okay, you will find responses like say analyzing, synthesizing, and then crafting and so on. Okay, and they come with a token limit of 1 million token per share, right? Per chat. Okay, that is the another limitation. Now let us say if you want to overcome all these issues, what is the solution? So we have a solution, what they call it as the RAG approach, okay, or retrieval augmented generation. So which is an engineering technique, okay, which you can adapt for addressing all these issues. So what do we do in case of a RAG? Okay, we retrain the model, some existing model, okay, which you can download, okay, and then you retrain it with your own existing data, own personal data, organizational data, okay, and address all those issues whatever we have talked about, right? So let's say again, the data which you want to use, again, it is big in volume. What you need to do is you cannot give the entire data in a single go. So you need to divide that data into small chunks. And that is what they call it as chunking. Okay. So what is chunking? It is basically dividing large documents into small chunks. Okay. Typically, now this size may vary. Okay, depending upon the amount of data available. Let's say 500 tokens. Okay, but again, that is not enough. That is not enough. So many times, okay, you need to go for what they call it as the chunk overlapping. Okay, so in chunk overlapping, what do we do? Okay, we let's say we have divided the chunk or the chunk size we have considered as 500 tokens. So we will have an overlap of approximately 50 odd chunks. Okay, why this overlapping is needed? Okay, this is simply needed to understand the connectivity between two different chunks. Okay, so as to keep the connectivity, okay, you need to have this chunk overlapping, and then the rest of the things are as we have seen in case of large language model, that is embedding vector database, and then you may use any of the searching mechanism like say similarity search or a Euclidean system distance or maybe cosine search or anything whatever you feel appropriate for that purpose, right? So having said this, you can build your own large language model using this particular RAG approach, right? That is possible. Time permits, definitely we'll have a look at this. But the another important aspect, okay, which with regard to RAG, okay, this slide will give you an idea. Okay, wherein the user fires the query, it goes to the retriever, and from there it goes to this is the you can say the additional database or the vector database which we are creating. Okay, so the desired chunk of the data will be extracted, and again it is given back to the retriever from where it goes to the user. Right. Now, let me give you one simple analogy to understand this RAG architecture. So, RAG is very similar to, you can say the LLM, you may consider it as a closed book examination or the traditional examination mechanism. Whereas RAG is a open book examination, wherein the student can carry a number of books, okay, and they will use as per the need, okay, depending upon the question, okay, they are facing, okay, they may go through a number of books and accordingly they will craft the answers. So it is RAG is very similar to a open book examination. Okay, probably that will help you a lot in understanding what RAG is all about, right? So having said this, whatever issues we have discussed with regard to LLMs, all those issues are addressed by this approach, that is the RAG. So the advantages of RAG are nothing but the issues which we have faced in case of LLM. Okay, so we have enhanced factual accuracy, reduced retraining needs, improved response consistency, secure use of private or proprietary data. Why I'm saying secure use of proprietary data? Because your data is within your own control. You are not giving it to any third party, so they can so you will be sure about how it is being used. Okay, so it is completely secure use of proprietary data. Let's say your sales figure you do not want to disclose with any because it is your business secret, right? So it may harm your future strategies, right, and so on. So RAG has got a solution to all those issues. Then you get better domain accuracy. Then real world deployment is possible. The structure is modular. So definitely it is flexible. You can retrain it again after 3 months and so on, right? So and then you may reduce the hallucination risk. Okay, transparency and explainability is there. Future proof architecture is there. So this is the overall scenario of this, you can say the RAG architecture. Okay. And now how to use all these tools. Okay. Having said this, so we have started, if you recall, started with the traditional AI to the machine learning to the deep learning. Okay. And then large language model, and from there or the generative AI, okay, we faced a number of issues. We entered into an era of what they call it as RAG. So RAG is the solution to most of the problem. Again, RAG has got numerous problems, but we will not talk on those lines at this point of time. because we do not have sufficient time to discuss all those things at length. Right. Now, whether to use these things for research, probably this is one of the thematic area, okay, which we need to discuss. Okay. So using generative AI for research, okay, as far as you are not violating any ethical consideration, there's nothing wrong in that. But my simple take on this is you should not uh, violate the guidelines provided by various publishing houses. Let's say I want to publish my article in IEEE. Okay. So IEEE allows you to use this generative AI tool for only two purpose. And what is it? It is only for editing and grammar enhancement. Now I need to adhere to these guidelines. Okay. So each publishing house has got their own way of dealing with this, the usage of AI for or generative AI tool for research. For example, Springer has got its own guidelines, elsewhere has got. So simply adhere to those guidelines and do not violate uh, those regulating guidelines. Okay, that is the best way of handling this issue. But whether you can use it for education, the answer is yes. Okay, there's nothing wrong. Okay, whether you can use it for student assessment, for creating quizzes, assessment question papers, again there is nothing wrong. Okay, so teaching learning, there's no problem. But you may say for research, okay, you have to have your own boundaries. Okay, so you need to define your own boundaries and so on. So this is a list wherein we have got certain tools. Okay, again, this is an indicative list. There are many tools. Okay, there are hundreds of tools available. Okay, but let's say if you want to use it for research, we have Consensus, Elicit is there, Research Rabbit is there. Okay, and so on. Right. So you may use all these tools. Okay, without violating the, you can say, the guidelines provided by various publishing houses. And so on. So with this, we are almost done with the session. If you have any specific query with regard to whatever has been covered in the session, you are free to ask. Okay. Because I'm almost done. Okay.
Dear
Now the forum,
participants,
yeah,
if you have
the
any
forum
queries or
forum
questions,
is open for discussion. Yes,
yeah.
forum is open for discussion. Let me stop sharing. Actually, there are few frameworks which I wanted to share with you, but you can explore it later on, like say Olama.
Kindly put your dear participant, if you have any query regarding this session, then you can raise your hands and write your question on the chat box.
Or otherwise, if you can unmute yourself, okay, there's nothing wrong in that. You can unmute and okay, I'll try my level best to, yeah. But by that time, let me share a few more things with you. That is, you can explore this Olama framework, okay, since we do not have sufficient time, otherwise I would have demonstrated. So this Olama is a fantastic framework, okay, which is free and open source. Okay, Olama and LM Studio, these are the two frameworks which you may use for building your own large language model. Okay, you can create your own large language model using these frameworks like Olama and so on. Okay. And they are freely available because they are built on, yes, something is there. Lot of thanks, sir. Sir Kumar ji. Good afternoon. Unclear volume. There were issues with regard to my voice, but I think I have confirmed it before proceeding further. Okay. Am I loud and clear? Okay. One new, two
Yes, sir.
new, Thank you, sir, for the session. So I presume that there are no more queries. Okay, now with this, I hand over the proceeding to the organizer. No, sir, voice was clear. Okay.
So there is one question from a
Yeah.
participant.
How does prompt engineering intersect with academic integrity when students use AI to generate assignment? And that's why I said, being a teacher, you must be aware about these tools, right? So there are solutions possible. Like say, if you put anything submitted by your student, okay, if you put it in some flag check, okay, it will categorize it as a AI generated stuff. Okay, because this is happening every now and then. The students are using it, okay, but definitely if they are doing so, definitely they are making some compromises on academic integrity front or the ethical use of these tools, right? So you must be aware. Okay. So if you go through this stuff, you can very well understand, right? You can very well understand. Or otherwise, let's say if the documents are little bit big, you may put those documents into flag check. Okay. The plagiarism checkers are nowadays equipped with this AI detection functionality. Okay. So it will be categorized as AI generated stuff. Okay. And it will increase the similarity index of that document. Okay, so probably okay, that is the only way. Okay, you should be very keen while assessing all those assessments. Okay, or otherwise you can make use of the flag tool as I have told you. Right. So you may use Turnitin or Authenticate. Okay, and these things are available for institutional usage free of cost. UGC has provided access to all these tools, right? And that too free of cost. So you may use all those tools for identifying whether they have written on their own or it has been generated by some AI tool. I hope I have answered your query, ma'am. There is no other query in the box. Okay. So have you tried something on Olama? I'll show you how safe it is to work with Olama. Okay, if you download Olama, okay, simply Google Olama free download. I will take 2 to 3 minutes. Not, I don't know how much time we are left with, but right now, whether you are in a position to see my entire screen, okay, if it is so, yeah, if it is so, then simply go to Olama free download, right? Click on the very first link, okay. Download this Olama for Windows. If you are using Windows platform, if you are using Mac, okay, you may use, you can say accordingly, the links are available. Linux, again, link is there. Download this file, install it on your machine. Okay, double click on the executable file. Okay, there is no rocket science involved in that case. Simply click next, 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 and install it on your machine. Once you are done with that, populate it with various models. These are all free and open source models. Okay. So if you click on models, you will find numerous models. Right now, I'm showing you on the Olama website. Now, these many models are available, as you can see. Okay. So what next you need to do is you need to populate it with various large language model. Now, once you are done with this, okay, you are completely secure. Now, you don't require any internet connection. Okay. Because the biggest problem with all these online tools is your security and privacy is always at risk. Okay. So if you do not want to make any compromise, or let's say you want to carry out something which is of confidential sort, let's say you want to set question paper. Okay. So you can use this Olama along with certain tools. I'll show you
Sir,
whatever.
the screen is not visible.
Is it? but I'm sharing my screen.
Okay, sir.
Let me check later. Oh, actually it was a window. Okay. Now I need to share my entire screen. Is it visible now?
Yes, sir, it is visible now.
Yeah. So you need to download this Olama, okay, which I have told you earlier. Okay, simply Google Olama free download. Okay, download the Windows version, but don't try it on lower configuration machine. These tools are very resource hungry. That is, minimum you have to have Core i7 processor with 8 to 16 GB of RAM and sufficient amount of hard disk. Okay, sufficient amount of hard disk. So once you have installed it, okay, I'm sorry for the interruption, but anyway, so probably my screen is visible to you. So what I was trying to emphasize here is that is once you install it, okay, if you say Olama and if you run it, okay, and what next you need to do is you need to populate it with various models. Say for example, in this case right now I have installed Llama 3.2. So that will be loaded. Okay, it is resource hungry. Definitely, it will take more time. And then once it is loaded, okay, you don't require any internet connection. Now, as I was referring to, that is, you can create your own large language model using this. Okay. So if you go to command prompt and simply type Olama, okay, let me show you those lines. CMD, and so if you type Olama here, it will give you the list of command available. Create a model. Okay, create is the command which one can use for creating a model. Create and then Olama create and then the name of the model you wish to create. So this tool is very powerful and it will help you a lot in protecting your privacy and security. So this way again LM Studio is there. Exactly on the similar line we have got a LM Studio. Again you can download LM Studio free of cost. That is again built on free on open source philosophy. So there are many tools. Okay, there are many tools, but since we do not have time, okay. So with this, I thank you all, okay, for patience hearing, and now it's over to you if somebody is there.
Okay, sir. I extend my heartfelt thanks to Dr. Mohammad Atique for delivering such an insightful and inspiring session. Your valuable knowledge and practical insights have greatly enriched our learning experience. Sir, your presentation helped us understand the immense potential of generative AI and transforming teaching, research, and innovation. Your practical insights into the responsible and effective use of AI tools have inspired us to explore these technologies with confidence and creativity. I also express my sincere gratitude to all the participants for this active participation.